We're starting vectors. The first question says A, B, C, D, E, F is a regular hexagon with center O. AB is equals to P and AF is equals to Q. So first we'll draw the diagram for this. The center is O. Let's have this as A, B, C. AB is equals to P and AF is equals to Q. Now we have to find first find AO. So for AO, this is AO. Now in a regular hexagon, this length and this length are equal. Therefore, this FO can also be called P. Now for AO we have to add AF plus FO. So therefore AF plus FO, AF is Q and FO is P, so AO is Q plus P. Now next is AC. AC is this length for AC. We have AO as Q plus P and OC will again be equals to P. So AC equals to AO plus OC therefore AC equals to AO we found as Q plus P plus OC, that is P, so AC equals to Q plus 2P. Now third is AE. AE is this vector. For AE, we need AF plus FE. AF we have as Q plus FE. Now FE will be equals to AO. FE will be equals to AO and AO is Q plus P. So Q plus P equals to 2Q plus P. This is AE. Now the last part is find CE. Now CE is this vector. For CE equals to CD plus DE. Now CD is equals to AF, so CD is Q and DE is the reverse of AB, so ED would be P, DE is minus P, so Q minus P, CE is equals to Q minus P. So that is the question. Now the next question has this diagram. It says that OC is equals to C and OD is equals to D. OC is to CP is 1:2. Means that if we write the vector CP would be 2C and OP will be 3C. OD is to DQ is 2:1. So DQ, the vector DQ will be D upon 2. And CD equals to DR. Now first part we have to find in terms of C and D, OP, OQ and OR. Now for OP, the ratio of OC to CP is 1:2. Therefore CP will be 2 times OC. So this is 2C, this is C. OP equals to OC plus CP. OC we have as C and CP, because it's in the ratio 1:2, so CP is 2 times C. So plus 2C. Therefore OP equals to 3C. Now the next part says find OQ. Now the ratio of OD to DQ is 2:1. Therefore DQ is half of OD. So DQ is D upon 2. So OQ will be D plus D upon 2. This is equals to 3 upon 2D. And the next one is OR. OR is this vector. For OR, we need OC and CR. First we'll have to find CD. CD will be equals to CO plus OD. CO will be minus C plus D, so D minus C, that is CD. Now we are given that CD equals to DR, so CD plus DR, that is CR, will be 2 times D minus C. Now for OR, we need OC plus CR. OC is C plus CR is 2 times D minus C. So equals to C plus 2D minus 2C equals to 2D minus C. So this is OR. Now the next part says show that P, Q and R are collinear. Means that P, Q and R are lying on the same line. Now for this what we'll do is we'll first find PQ. For PQ, we'll have OQ minus OP equals to OQ we have as 3 upon 2D minus OP we have as 3C. So if we take 3 common, it's half D minus C. This is PQ. PQ equals to 3. Now next we found PQ, now we'll find QR. QR equals to OR minus OQ. OR is 2D minus C, minus OQ is 3 upon 2D. So this is 2 minus 3 upon 2 is half D minus C. This is QR. Now what we can see over here is that PQ is a scalar multiple of QR. That is why both of them are parallel. Now if PQ and QR are parallel, that means that PQ and R are collinear. The next part says find the ratio PQ is to QR. Now for this what we'll do is we'll divide PQ by QR. PQ is this and QR is this. Now this got cancelled. The ratio is coming 3:1. PQ is to QR. The next question says find the relationship between P and Q if the vector PQ minus 3, 5 is parallel to 3, 1. First we'll simplify this vector. So this will be equals to P minus 3, Q minus 5. Now if this is parallel to 3, 1, that means that multiplying 3, 1 with a scalar will give us this vector. So we'll equate this with K times 3, 1, or this can be written as 3K and K. Now P minus 3 equals to 3K and Q minus 5 equals to K. So over here K equals to P minus 3 upon 3. Now if K is equals to K, so P minus 3 upon 3 is equals to Q minus 5. Shifting 3 over there, 3Q minus 15. So shifting 15 over here, this becomes 12 equals to 3Q minus P. That is the answer of the first part. Now the second part says the vector P minus 1 Q has magnitude 2. Now to find the magnitude of this vector, what we will do is we'll square the x value and the y value, add them under an under root. This is equals to 2. Now this square root will be shifted over there. It will become a square. So 2 square will be 4. Now P minus 1 whole square, we'll apply A minus B whole square identity. P square minus 2P plus 1 plus Q square equals to 4. Now P square plus Q square minus 2P equals to 4 minus 1, this becomes 3. That is the second answer. Now unit vector is a vector that represents direction, and the magnitude of a unit vector is always equals to 1. Now two basic unit vectors are I and J. I represents the eastwards direction, that is moving towards the right on the x-axis, while J represents the northward direction, that is moving upwards on the y-axis. So if this is a graph, we have a vector which, and the head of the vector is 2, 2, then the position vector of this point of this vector will be 2, 2. So that is that on the x-axis it is moving 2 blocks, the upper value shows that, and on the y-axis it is moving 2 blocks, the lower value shows that. Now we can also write this as 2i plus 2j. So 2i means that on the x-axis it is moving 2 blocks towards the right, and 2j means that on the y-axis it is moving 2 blocks upwards. Now if it was minus 2i, that would mean that the vector had this direction. And if it was minus 2i minus 2j, then for minus 2i minus 2j, the vector would be moving like this. So I and j are unit vectors. I represents one block on the x-axis towards the right, and j represents one block on the y-axis upwards. Now from this we've learned that if, for example, we have a vector xy, we can also write it as xi plus yj. Now to find the unit vector of this vector, a vector quantity contains a magnitude and direction. So a unit vector represents direction. Now to find that unit vector, what we'll do is we'll write direction equals to vector, and this magnitude will move over there in the division. So this will be the unit vector. Now vector we have as xi plus yj. For the magnitude, if for example this is vector a, the magnitude of vector a is equals to under root x square plus y square. So now we have the vector and we have the magnitude. Now to find the unit vector, it is represented like this. We'll divide xi plus yj by under root x square plus y square. So this is the general formula for a unit vector. Now if we take a question for this, A is a position vector 3, 4. Find its unit vector. Now for the unit vector, we first have to express it in ij form, so this will be 3i plus 4j, and for the magnitude of A, what we'll do is, so the position vector, so OA, so for the magnitude we'll have under root 3 square plus 4 square equals to 5. Now the unit vector of OA will be equals to 3i plus 4j upon 5. This can also be written as 3 upon 5i plus 4 upon 5j. So now, as we read earlier, the magnitude of a unit vector is always equals to 1. So now we find the magnitude of this unit vector to check if we have the right answer. For the magnitude, we'll have 3 upon 5 whole square plus 4 upon 5 whole square this is coming equals to 1. So we have the right answer. The next question says OA is equals to 4i minus 21j, OB is equals to 22i minus 30j. The point C lies on AB such that AB is equals to 3AC. We have to find OC. For this, we'll write AB equals to 3 times AC. AB equals to OB minus OA equals to 3 times. AC is OC minus OA. So OB, we'll shift these vectors in the form of column vectors. So OA will be 4 and minus 21, and OB will be 22 and minus 30. Now OB minus OA, so 22 minus 30 minus OA, which is 4 minus 21, equals to 3 times, we have to find OC, and OA is 4 and minus 21. Now 22 minus 4 will be 18, minus 30 plus 21 is minus 9, 3 shifted over here will become 1 upon 3 equals to OC minus 4 minus 21. 18 into 1 upon 3 is 6, and minus 9 into 1 upon 3 is minus 3, plus 4 minus 21 equals to OC. This is equals to 6 plus 4 is 10, minus 3 minus 21 is minus 24. So this is OC. In the form of INJ, we can write OC as I minus 24j. In the next part, they're saying find the unit vector in the direction of OC. So for this, we'll need the magnitude of OC. Now for the magnitude of OC, we'll have under root 10 square plus minus 24 square. This is coming equals to 26. So now we'll divide the vector by the magnitude. We can leave the answer over here, or we can simplify and check using the calculator whether the answer is correct or wrong. So for that, what we'll do is 10 upon 26 whole square plus minus 24 upon 26 whole square. This is coming equals to 1. So this will be our final answer, or you can simplify it. Now there's one more concept of using simultaneous equations to find constants like lambda and nu. So this is one question like that. Now we are given this trapezium and we have to find dA in terms of A and B. dA is in this direction, so it can be DC plus CB. So dA equals to DC plus CB plus BA. DC plus CB plus BA. DC is 7A. CB will be minus B. And BA will be minus 4A. Therefore, dA equals to 3A minus B. Now for dB, we need dA plus AB. A we found as 3A minus B, and AB we have as 4A. So this equals to 7A minus B. So D A equals to 3A minus B, and D B equals to 7A minus B. In the next part, we are given that AX is equals to lambda times AC. We have to find AX in terms of A, B and lambda. This sign is lambda. Now AX equals to lambda times AC. AC will be equals to AD plus DC. So AD plus DC equals to lambda times AD. DA is 3A minus B, so AD will be B minus 3A, and DC is 7A. So AX equals to lambda times 4A plus B. Now the next part says find in terms of A, B and lambda dx. Dx is equals to dc. Dx is equals to dA plus AX. dA we found as 3A minus B, and AX we found as lambda times 4A plus B. So 3A minus B plus 4 lambda A plus lambda B equals to, we'll take A common from these two, so 3 plus 4 lambda A plus minus 1 plus lambda B. This is dx. Now in the next part we're given that dx is equals to nu times dB. This is nu, and you have to find the value of lambda and nu. So dx is 3 plus 4 lambda A plus minus 1 plus lambda B equals to nu times dB. Now dB we found as 7A minus B, so 7A minus B. This can also be written as 7 nu A minus nu B. Now we'll compare the coefficients of A and B. First comparing the coefficients of A, so 3 plus 4 lambda equals to 7 nu. Then comparing the coefficients of B, lambda minus 1 equals to minus nu. So now we've got two equations that we'll solve simultaneously. First we'll simplify these, so 4 lambda minus 7 nu equals to 3, and lambda plus nu equals to 1. Now the first equation is 4 lambda minus 7 nu equals to 3, equals to minus 3. And now this one we'll multiply with 7. So 7 lambda plus 7 nu equals to 7. Now adding these two equations, these get cancelled out. We have 11 lambda equals to 7 minus 3 is 4. So lambda equals to 4 upon 11. And for nu, we'll use this equation. We have lambda is 4 upon 11. So nu is equals to 1 minus 4 lambda. 1 minus 4 upon 11. Minus 4 upon 11 is, so nu is coming equals to 7 upon 11.